Good morning. Welcome to today's webinar. Today we'll be covering Chapter 10 of the Design and 3D Modeling course guide. This chapter deals with preparing files for basically the deliverables that we're planning to give to construction. These are the files that would be used in construction for automated machine guidance machines, for their equipment. This picture here shows essentially a job that we visited where they had taken some design files from a consultant and imported those into their equipment. And we asked them a lot of pointed questions about what type of files they commonly would like to get, and took the knowledge that we learned from there as well as several other resources and came up with a procedure that we'll talk about in this next hour. As you can see on this image, this shows the actual equipment down here. This is the actual project site as it would appear on a 2D plan sheet. And then it's also tracking the proposed surface for this particular project, and it helps the grader decide where the blade needs to, what the depth of the blade needs to be on the existing ground, and so on and so forth. This picture also shows the receiver here that's mounted to the equipment. So this is really the impetus of our future technology, and we're preparing to deliver our plans in a 3D mode. So this is sort of a little bit of the background in a Reader's Digest version. But I wanted to at least call to your attention that we now have in the 2015 CAD Manual a specific section 5-12 on what 3D deliverables we're asking consultants and our internal designers to prepare, and where to put them and what they should be called, and a lot of the specifics. This CAD manual came out in February and has been posted out on our internet site. If you go to the ECSO website, you can go to publications and find it there. Here's the actual entire manual, and then if you go to 5-12 or 5.12, it's production, and then down in that particular chapter is 3D deliverables supporting automated machine guidance for 3D projects. And then we give specific information about where to put them. So this is a new folder that's created in the project folder structure. If you create a new project, if you have an existing project, all you have to do is basically go create this under the root of the project, and I'll be referring to that several times, so you'll see where that's actually located. And then there are specific files we're asking to provide for the contractor. One is the actual alignments, profiles file, the 2D proposed plans, planometrics, the 2D existing planometrics, which would be like the survey file, the topo file, utility files, and then the 3D existing surface, which is really just your terrain exported to a land XML. And then we'll talk about your 3D proposed surface, this one actually right here, and how to create it. Dependent upon the contractor and the equipment they use, some of them can read DGN files directly, some would rather get DWG files. At least in the course guide, we're showing you how to create both. So that's the existing surface, and you can deliver the DGN file of the break line of the existing surface and DWG as well as an XML, and that pretty much gives them all they need. And as far as the proposed surface and the break lines that make up that surface, it's really the same thing that you have for the existing. It's just broken into two different things here. One is the terrain as an XML, and then the other is the break lines that make up the terrain rather than the corridor mesh objects, and we'll be talking more about that as well. In this chapter is also some guidance for how tight to make your model. If you're designing a urban section in your normal tangent sections, we're asking that if it's a lower design speed, that you would set your interval to a maximum of 10 feet. You're welcome to set that maximum lower if you want them to be 5 feet. It's up to you. On curves, horizontal curves that is, 5 feet. Anything that has sort of intersection details, driveways, you might want to go down to 2 feet to get the desired accuracy or the desired smoothness of the model for when you deliver the 3D break lines and such. There's also a section in here on quality control, and we're not going to get into a whole lot of details about how to verify the model against the plans, but we did list a few things in here. You know, from our perspective, if you're designing a project in 3D, the plans should usually be, or it should be, an output of the 3D model. We do understand that there's a 2D, 3D sort of workflow going on there, so here are a few techniques for verifying that the model matches the plans. At the end of the day, what we sign and seal is going to be a project PDF, which is based on the contract plans. The models are going to be delivered for the contractor's use, and at this point, he will take responsibility for the models. So any dispute will go back to the plans, what the engineer signed and sealed. The models are being provided so that the contractor doesn't have to take our 2D plans and create models from them. And he basically can leverage the work that was done in design and use it into construction, and basically use if he has automated machine guidance equipment, he can go ahead and import those files directly and have it work with their equipment. If you follow the course guide in Chapter 10, these slides basically are just bullets of what I want to kind of go through as far as how you would create each of these different files. So I'm going to get into a session here. And this is my pseudo final design for my project. At least it's going to be in the final design for this session anyway. There are some more details in here that I would want to work out. I've got some crossing break lines and things like that, but this is more for workflow than it is for, you know, the final design in your model. But the first thing that we want to do is get the alignments, the controlling alignments for the two corridors or our main roadways here, and export those into a land XML format. So it's very easy in SS3. All you have to do is select on the controlling alignment. In this case, this is this complex element, State Road 61. It has an active profile, State Road 61 on our PR. We've been building this through these webinars and through this course guide. So this is something we did way back in Chapter 2. We built this centerline alignment. So all I have to do is click on this alignment and wait for the context menus to come up. And if you go over to the reports option, there is horizontal geometry reports. You click on this button here, it's going to bring up a civil report browser here. And then there's several ways to review the centerline data. Okay. The one way to do it here in this case is to show the alignment to a land XML format. So as soon as you click on this button here, it basically is providing it in a standard land XML. In this case, it says 1.1. So that's as long as it doesn't go over version 1.2, we're good. And preferably, if we had a style sheet that was 1.2, it'd be okay. But I'm going to show you, after you create these land XML files, we've also provided a viewer in our workspace that you can validate the land XML files such that they're in a common land XML format that most of these machines will be able to read in. But when you do that, you're going to do File, Save As. Once you have formatted this report, you'll do File, Save As. And then you're going to basically save this file to the name in the CAD manual. So in this case, this would be AMG, and I have already done it here, so I'm just going to click on this one here. AMG-alignment, and if you want to put State Road 61 or 61, however you decide to do it, I'll just go ahead and make a new one here since I already created this one. And I'll put State Road 61. And notice that I'm not changing the save as file type. This is important because if you actually click on this view, you're going to see an XML version of it. But this is for a web page XML, so it's been reformatted. So you really need to save it in the native, if you will, ASCII text file, but give it an XML extension. I'm going to repeat that again. When you save this as an XML, you want to name it XML and leave it as text. Do not change it to XML because this is a web page format XML, not a text file format, XML. As soon as you choose Save, then it essentially saves it to a text file, a .xml text file. And if you were to go and look in your current working directory and go back into the project directory structure, this is where this 3D deliverables folder is. It's right under the root of the project. And when I open this up, you're going to see I have several files. These are the backup, the 3D deliverable files that we're going to create in this session. And here's the new one that I just created, okay? And if you open this up with an editor, you'll see it should look exactly like, open up on the other screen here. You'll see it should look exactly like what it looked like in the report browser. And if you scroll down, if you look at it, it has all the start station, end station, it has the profile information is down here, and any curve data that's in there. And so that is a valid XML file format. So once I've done that with both the center lines, then I have the alignment saved to an XML format. Okay. So the next thing will be to create the 2D files. All right. And what I'm showing here is, so the alignments were pretty simple. Creating the 2D files, it's really just a matter of what I'm saying here, create a save view, and I think I have one more bullet point here, right here. So there's an asterisk here. Basically, you're going to try to create a save view with certain references off, levels off, construction elements off, and basically preparing it such that only the 2D planimetrics that you want to show as a proposed plan would be present and viewable, and then create a save view for it. And once you do that, then we can basically put a fence around it, copy it to a new file. And the reason we do this is to drop off all of the, what I call civil element data. So what I say, uncivilize it. And really what that's doing is it's dumbing down those elements that have DDB information and feature information to nothing more than just CAD lines, microstation lines, and arcs, and whatever other type of elements that are basic CAD elements. Because by doing that, they'll then be in a format, DGN, or a raw DGN or a raw DWG, such that an ordinary program like TopCon or one of the other construction equipment software vendors can read those in and display those a lot easier. If you were to have all the civil features and the DDB stuff on there, it's likely they wouldn't be able to read those anyway. So we're just dumbing these down. So I'll just show you that process. Okay, so basically what you're going to want to do is you don't even need this 3D view anymore. You're going to work completely from the 2D view. And then the first thing I said is to go in and start turning off references that don't have anything to do with it. And then the next thing would be to turn off your construction elements. And we have a F7, or you can go to your view attributes and turn them off this way. You can then go and turn off anything else, like maybe I don't need the baselines, I don't need the center lines because they're really part of the alignment data. Maybe I don't want to show these existing pavement markings, so I can turn off these pavement markings. And anything else, like in this case, you're seeing that there are corridor template stages. Now those are construction class elements, so they're not showing anyway, but for safety I would probably just turn these off. And I would just make sure I have only the items in the display that I want to basically export to what would be called a 2D planimetrics. And what I did is I went ahead and created a save view in my final design file, so that if I had to do this again, I could automatically just come back to that same view settings. And then I just created a save view, and I just double click on it and then click the view. And now I've basically got that file prepared to create the automated machine guidance 2D file. And then all you do is just go out and create a fence. And I just draw a fence like this. It remembers an old fence that I had out there, so I don't want to worry about that. And then in the fence tools, you can either, old school, you can use the key in FF equals and give it a file name, or you can use the new, there's a copy move fence to file under the fence tools, and it brings up this dialog, and then you'll just browse out to the 3D deliverables, and you'll select well, in this case, I'm selecting one, but you're going to, for this particular file here, according to the CAD manual, we're going to call this the Automated Machine Guidance 2D Design 01 file, okay? And once you have that, you just choose Save, and it'll ask you to select the view, and you will basically create it. I'm not going to overwrite it because I already have it out there. And then once you have that, in order to get the 3D view, you're going to open up this file that you just created. And so that's going to be under the 3D deliverables. In order to create the DWG file, you're going to open up the DGN file and just do a file save as. All right, so this is, and it has this extra view, so I can turn this off, and I can fit this view here, and Control F, and it'll save the settings, so the next time I get in it, it'll always be in this orientation. And it's going to have all the planimetrics necessary for the construction equipment to follow basically as 2D lines. To create the DWG, it's just a matter of going to File, Save As, and changing the format here to Autodesk DWG files. And then you'll just give it a file name. Basically, it's going to use the same file name with a .dwg extension. Choose Save, and then as soon as you create it, the one thing that I do to validate that it's been created, it's always going to bring up this dialog here, and you want to make sure it's set to survey feet because that's the units that we work in. And if you check this box, it'll always go to survey feet. I leave it open just to verify that it actually creates it. And then you'll see that now I'm in this DWG work mode. So I have a DWG file open, which I like to see because then I can go in here and I can verify that the level names are basically accurate and they look correct, so that if I had to give a DWG file just to a contractor, I would know that it looked like my proposed planimetrics, and it gives me a way to kind of do a QC on it. That is the 2D planimetrics. You could do the same thing with the topo file, the existing utilities file, and the existing right-of-way file. You could create dumbed-down DWG files using the same workflow methodology. And that's basically what the CAD manual is saying. Okay, so now let's talk about the 3D files. The next exercise in the course manual is exporting the 3D break lines. And in order to do that, I'm going to open up the final design file again. And I'll flip back to that slide. One of the additional steps in here is to make sure that your corridors are saved to a final stage. Because what we've got to do when we have multiple corridors, we actually have to create the 3D break lines for each of the corridors and then make sure that they merge into one another accordingly, because the contractors can't necessarily read at this point in time the corridor meshes. We want to make sure we've got the final design stage, which is going to be the tightest interval on our corridors first. And that will also create, like last week we created that intersection, that will also create a better intersection model off of the tighter corridor models. If you remember, we were using the corridor break lines, if you will, the corridor surfaces to create the terrain surface. And since they're all sort of ruled, what I call ruled together, that if you have a better corridor surface, you're going to get a better intersection surface, which is going to give you better 3D break lines. So you want to make sure that you set your final stage, your stage to final. And then it's the same workflow as we did with the 2D files. We're going to create saved views, and this is a step where you rotate to a top view, you turn off your references and levels and construction elements, so on and so forth, so that you only have in your saved view the 3D break lines that you need for the proposed surface. Okay, and I'll show you what I would do in that case. Okay, so I've already made sure that my corridor stages are set to final, and I can do that visually because of the way we color coded. If you haven't noticed, that white is preliminary, yellow is design, and red is final on the corridor stages, so that I can see visually right away that both of my corridors on my two roadways are set to a final design stage. If I zoom in, tighten up, I'm also going to see that the interval is actually down to 10 feet. And then at my intersection here, I've got at least 5 feet on these intersection radiuses. and all of these here as well. Some of them might even be a little tighter. So what I've got to do now is basically prepare this 3D view so I don't even need the view one anymore, and I can just start working with this one here. Usually we're in a rotated view, you know. In this view here, we're looking at it and verifying things, but what we want to do is make sure we get to a top view. And so you can just use the view rotation to go to a top view. And then we're going to start making sure reference files are off. So the only reference file usually that's turned on is the existing terrain boundary. So we're going to turn that one off. And sometimes your existing features, if you had just finished creating cross sections with existing features, you'll have that attached as well, possibly, if you're in this file doing cross sections. If you're in the cross section file, you probably don't. At any rate, you're going to turn off all your references. The next thing you're going to do is go to your construction class elements, so you can turn those off. And those are turned off already. And I would also work from a wireframe. So you can go to the view, and right now, usually with the F2 key, it sets it to an illustration, ignore lighting type mode. That's how you can see them shaded. So if you just go back to a wireframe mode, and then sometimes the background is white. If you want to set that back to black, you're welcome to, just with the F5 key. And then this is what I was saying about, these are corridor meshes, okay? If you actually click on one and go to element info, it'll tell you it's a mesh type object. These are not usually viewable by anything other than MicroStation or one of the MicroStation products. So what we're going to do is we're going to turn those off, and we provided a couple of easy function keys for that as well. We also, if you remember correctly, in the Project Explorer, I've talked about this several times, is we've organized our features by corridor components, corridor lines, 2D lines, which are 2D and profiles, and then also terrains. So really all you'd need to do is leave on the corridor 3D lines folder, and you would have pretty much everything you need, but you might have more than what you need. Okay, so if you turned off the corridor components this way, it's going to turn off all those meshes. This is going to turn off any profiles. Like last week when we were creating profiles on 2D lines, it was creating 3D lines in our view. And those are actually controlled with this Plan 2D as well, as far as the display. And then any terrains that we have in here, in this case there's only one, a DTM proposed, and it's already turned off with a construction class, but you could also use this as well. So that's one way to control how things are displayed. Another way is to use a couple of function keys that we created. We created an F9 function key, and what F9 really does, it goes in and it turns off everything that has a PX, which is basically where the components are, and any level that is PM is what's being displayed in the 3D model, okay? So that's a proposed model of the curved flow lines. The other thing we did was we turned off any base proposed model. So the function key, really it's just going in and saying levels off, everything on the PX, and a couple of PM levels, which are basically the base PM levels. But it still leaves on some construction lines. It also leaves on the pavement crown. Some of those lines you might not want turned on. So you still would want to go in and basically tweak these levels. Text labels, we don't necessarily want that on. I would just verify that you probably don't want this miscellaneous on and the DTM level. So you could just set this as active, turn off this miscellaneous, and then probably there might be a default level that's turned on somewhere, selected, and that one actually got turned off. So once you have that, you've done it one time, and you know that these are, you can rotate yourself around and you can say, all right, looks like everything in here, there's a ditch line or median crown line, so there's actually a flat ditch in here. And then I have a cut line, I have my sidewalk lines. There may be some additional lines out here, shoulder unpaved. There may be some lines out here that really don't represent what you're trying to do. In that case, you would just kind of go through and use your judgment as to what the contractor would need as brake lines to either build the surface from the brake lines or drape them onto the proposed surface so that he would have lines to follow. And if you remember back on that image, the very first image of the slide, you could see that view, and that view is what they're really looking at. They're going to create the proposed surface from these lines. It looks like I have some extra lines in here that I'm not really going to worry about at this point. You can see where some of these break lines are crossing down here at the intersection. This would all need to be cleaned out. But all I'm really trying to do is show you the workflow to create the file to put in the deliverables folder. So I also created a save view once I had all this set up, and I called it 3D break lines. So if I double click on that and click this view, now it's going to give me everything prepared so that the next time I get in the file, I can just go to Save View, 3D break lines, all my levels will be on correctly, and then I'll just be able to use the file fence utility. And once I have that, I can go ahead and do a create copy file contents to a file. And then I'll go to the 3D deliverables, and I'll select a 3D. The only difference here between the 2D is that there's a 3 instead of a 2, and I'll just select that to save it and go ahead and replace it. Doesn't matter, it doesn't take long. Click in the view, and now I've created that design file. And just like we did with the 2D, I'll go open that file up and save it as a 3D DWG. So there's my 2D, there's my 3D. Open that one up. Close that view. And I can verify that this is a 3D file just by rotating around, and I can look, and the only thing in this file is the break lines now. All of them should be underbar PMs for proposed model. Okay, so all these lines are now proposed model lines. Go back to a top view. I just leave it in top view because I think it's just a better practice to be in. I don't know if it would matter if you were in a rotated view and put a fence around it or not, but I've always worked from a top view whenever I'm trying to create files of one another in a 3D file. So then it's just a matter of doing File, Save As again, and it's going to know to use a 3D DWG, so I'll just change this to a DWG and select, well, in this case I haven't created it yet, so I'm going to go ahead and save it in that deliverables folder. Again, I'll use survey feet, and then once it processes it, it's going to open it up in the DWG work mode, so that tells me that I'm in the actual DWG file. And then I can do the same thing. I can basically go in here and use the MicroStation tools to rotate it, and it is actually a 3D DWG file with the break lines for that file. And these are, of course, all of these lines got created by your template. In your template, we were very careful to featureize each of the points uniquely so that with this in mind, let me just go show you that. So look, if you look at your template, we were very careful back in the template design for every point we put in our template, we gave it a specific feature, and we always gave that feature an underbar PM. The reason, obviously, is so that when we went to create these 3D break line files, we would actually have all PMs left over in the actual view. So we were very careful to make sure our templates are set up with all PM point features. And I was just going to open up a template and actually show you those. Anything on the top of the surface should have, just like you would see a curb PM, and they can be the same. For example, all the top points of your curb can use curb PM, but anything that's below the surface, we used a feature called bottom PM. So we didn't care if it was below a pavement, below a sidewalk, below a retaining wall, below a curb. We called every point below the surface bottom PM. That way we could just turn those off at one time. And the reason for that, at one time we thought we would actually have specific bottom features. Let me just go back to the final, open that template back up. I do want to talk a little bit on this one point as far as what we think the contractor needs. Okay, so here is the State Road 61 template. I'll turn off these point names, and you'll notice that every one of the points on the top are going to have a specific feature name. And that's why we make sure that when you select, if you're creating your own, don't select any of the 2D features because the 2Ds and the 3Ds get mixed up in this list. You want to make sure, and unfortunately in this template point properties dialog, it doesn't give you the ability to look in by folder. Where if you remember when you're drawing features, you can select folders, okay? And I'll go do that in a second too. But you want to make sure you're using PMs for points. That's the one thing. The other thing is that at the bottom of these are all going to be bottom PMs. So anything below the surface is a bottom PM. The reason we did it that way is because the contractors that we spoke with in the construction industry, as a rule, they'll take the proposed surface, because that's all they've ever been given in the past, and because that's what they get from cross sections usually, and they're going to create a proposed DTM that they use in their software. Everything that they lay out is going to be a depth based from there. So if they've got to cut out the ground for the sidewalk, they're going to find out what the sidewalk lines are on the proposed, and then all they have to do is tell their graders to go 4 inches below the top, and the blade will cut out for the bottom of the sidewalk. And the same thing for the base and for the pavement. So they do a depth from top of surface is what they're doing. So we don't even need to worry about these bottom points. If the one reason why we did put them all as bottom PM is if someone ever wanted a subgrade surface where it was basically just showing where the top of subgrade was, we could display all the bottom PM points, create a terrain surface from that, and provide them with that surface. So you'd have that ability to do so, because all of these would be bottom PMs. The other thing I was saying was about features. When you draw features, if you look in the feature definition list, you're going to see that there are corridor 3D lines and there are 2D lines. These also should not be used when you're drawing in 2D, because these are all the lines for the 3D. And that's why you want to make sure you're using all the planned 2D lines here. I wish there was a way that we could hide this 3D, but because they're linear elements, both types of linear elements show up in this feature definitions folder, and they both show up in the corridor create template dialog whenever you select on a point. All right, so let's look at where we're at here. We've got our alignments in XML. We've got at least our 2D design in a DGN and a DWG. Our 3D break line files now are in a DGN and a DWG. So now we're going to talk about our terrains. And these are your existing surface and your proposed surfaces. Well, the existing surface is pretty straightforward. All you're going to do is go into your existing terrain file. And this we did way back in Chapter 1, where we created in the survey folder this GDDTM 02. This is the one we got from the surveyor, which was all the triangles, microstation triangles only. It wasn't a terrain. This is the terrain that we imported to the design file from a TIN file. So I'm going to open that up, and currently the only thing we have displayed is the boundary. I'll just show you that it's it's the active terrain, but if you go to the properties, I can turn on the triangles, turn them off. So this is actually an SS3 terrain element. Turn on the flow arrows if I want, turn on the contours if I want, but it doesn't matter. When it's a terrain element in the design file, all I have to do is click on the side of it, and there is an export terrain model option here, and I can export it to land XML. If I can grab it while it's highlighted there. Export to land XML. And then you're going to essentially fill this dialog out, again, according to the design CAD manual. You're going to select this terrain model, tell it you want it to be a land XML. In this case, it's the existing 01. It is going to be existing surface here. And as far as the option for exports, we're always going to export both the triangles. In this one, I think for the existing, since it's really just triangles, we can just do export triangles only. If you wanted to make sure that the contractor got all of the force break lines in the existing terrain, you would use both. So both is probably, I'm going to waffle there, but I guess I'm going to finalize on export both. And that's the way we have it written up in the course guide as well. And then you're just going to follow the prompts. Existing surface, and eventually it will open up the file and ask you for the file name that you're going to save it to, even though it looks like it's saving it to it in this dialog. You kind of got to do it over again. So I've already done it once, so I'm just going to select this name and save. then replace it. And that's how easy it is to do the existing surface. I wish that the proposed surface was that easy, but it's not. So now we're going to talk about the proposed surface. And what you'll first need to do is you'll have to create a sort of intermediate file, because we have all those break lines, and there is no terrain yet. All there is corridors and an intersection terrain. You might have an island terrain out there, but all those terrains, if you want to give it to the contractor as a proposed surface, should all be put into one terrain, or at least maybe divided up into corridors, so that all your intersections are all together with your corridor, and so on and so forth. So those have to be built, and the way you've got to build them is from the composite 3D lines that are out there. And the easiest way to build a terrain is to add from elements. And so in our course guide, we decided to go ahead and have you use the traditional AMG RDO1 file. You could go to your Create File project and make sure you're in the Roadway Design file group. And this one right here we've been using for 4 or 5 years now. We used it in the old corridor modeling tools to display the Roadway Designer DTM files. So in this case, we're going to create our terrain in the same files. And I already have one out there, so all I've got to do is file open. And it's in the roadway folder right here, AMG RDO1. And actually, I'm going to create a brand new one because that one's already done. I thought in case we ran out of time. So let me just create a new one here. I'll create a new one called O2, create it, choose OK, and then open it. And when I choose OK here, it's going to ask for this scale. And 3D models don't need to be scaled, so I set it to 1. And then I have the 3D break lines, and that's what I'm going to use to create the final terrain. So I'm going to reference in the DGN file that's over in the 3D deliverables folder that I just created of those break lines. So that would be this DGN file here of the break lines. So I'm going to open this up or attach it to this file and close this dialog. Make sure I'm in a top view and fit this view. So now I have all these lines out here. And if I were to create it right now, I'd probably end up with a really not very good DTM because I have a lot of these crossing break lines. So what I'm going to do is just show you the methodology. And all you have to do is, in this case, I'm going to just select these lines. And those are all the 3D lines that represent this one side of my project. So I could basically create 2 separate proposed surfaces and give them to the contractor. And what I'm going to do is create one here, and I'm going to call it Create from Elements here. This is a terrain tool, Create from Elements. And make sure that you bring them in as break lines. You can use a maximum triangle length. I wouldn't use 10 feet because the triangles form across the roadway. I would probably use more like 50 to begin with. And then it can be a DTM proposed, and it can also be that feature name. I guess I could call it SR61. And then data point to add those elements to the terrain. Bring them in as break lines, maximum triangle length 50. And I should end up with a DTM here. Now, you might end up with, like in this case, I've got some of these triangles crossing here. So what I like to do is I like to turn off the construction class, which is that DTM. It's still out there in the file. Go to the levels and make sure I have all my levels on here. Oh, I've got to look at the reference file, my bad. So in here, you're going to see cut and fill lines. So I'm going to turn off all these lines and then just turn on the cut and fill. The reason I'm doing that is because now I'm going to select each of these cut and fill lines and add them back to the surface as boundary lines. And the way you do that is you select this tool here, Change Feature Type. And this will prevent them from basically triangulating across these cut fill lines. So automatically it finds the number of elements here, and then all I have to do is basically it knows that they're part of that DTM proposed surface, and I just basically change those from break lines to boundary lines. And it's just a matter of doing that, and then the surface retriangulates, and you'll see now that it's actually forming the triangles inside of my cut fill boundaries. So it's like a two-step process. You select all the lines first, create the DTM with a maximum triangle length, and it can be 1,000 for it doesn't really matter, as long as it forms the triangles across the break lines, whatever the break line distance is. Once you have those, you just isolate your cut fill lines and you add them back into boundaries, and then it retriangulates and you have your proposed surface for that particular part of your proposed design. And it is a 3D surface. If you zoom in here, you'll see there's my traffic separator and my curbs, and all the detail is there. So that once I have a terrain, then I can use the same export to file function. And in this case, instead of doing it from the boundary and bringing up the context menu, I just wanted to show you that the export to file is also over here. And then you just select the terrain. Here's the one that I just created. Tell it the file type. And here you can actually export to different file types out here. There's MX, Inroads, JPEG, Land XML is the generic format. And then you just give it the name here. Instead of existing, it's going to be proposed. According to the CAD manual, we want to call it proposed, PR. Cap locks always gets me. And it's going to be, instead of an existing, it'll be a proposed surface. And export both in this case, because we do want all those linear features in there. Follow the prompts, and it will end up bringing up the save as basically dialog, and we want to select or key in the name down here that's the same as the name in this dialog. I wish it would know that I wanted to do that, but it seems like I have to key it in twice. So there's the proposed.xml, and if I choose save, and it will say that it already exists, do you want to replace it? In this case, I'll choose yes. And now I have, if we go back to the slideshow again, so the files that we've created were these alignment XMLs, the 2D proposed planometrics. This is the one, that's the roadway design one we created. We did not create the drainage one or the pond design one, but if you had those, you'd create those as well if you wanted them to be separate. The existing survey files, we didn't create those, but it's the same methodology as this one here. You're basically just going to go in, turn on and off different levels, do a file fence, save as, put it in the 3D deliverables, and then open it up, save it as a DWG so you have both formats. The 3D existing surface, that was pretty straightforward. We just selected the terrain in that GDDTM file, did a save as, got an XML file. I didn't do the whole save the DGN. You could just take that triangle file and basically place it over there. So the main point is you're trying to just give them the dumb microstation lines that represent the triangles, so that they, if they had to, could create it or import it and not create their own surfaces from the XMLs. Same thing with the proposed. So this here is it's in the CAD manual. We think it's maybe optional, but we left it in the manual on purpose just so that they would have everything they possibly needed. And that's all of the files and how you would actually create them. But one last thing I did want to show before I go through the questions is that there is in our workspace, if you go to my desktop here and open up the f.ss3 folder, this is what normally gets delivered when the software is delivered on your machine. Is you'll see there's my geopack icons, my clear crash, to create files, all the normal things that you have in there. And if I go to a different view here, there's the icons. But there's a new one, there's a couple new ones out here. One is called this Land XML Viewer. And you won't have it on your machines yet. It's just something that we've added to the workspace and we're testing at this point. There's also a Create 3D Deliverables out here that is working with the other application, Civil, whatever that Autodesk application. Anyhow, I'm not sure we have validated this to work with f.ss3 yet. Something that we have to do. At any rate, the one I did want to show you was this XML Viewer, and this will be added to the shortcuts here in the future. But what we have done is one of the developers here in our office has created this XML Viewer that will basically open up any land XML file from whatever application that creates it. And if it's a valid XML file, it will actually display it in here. So I'm going to go ahead and try to open up some of these files that I've just created. So first I'm going to open up my alignment file here, and I'm going to see if I have an alignment or profile that looks anywhere like what my project looks like. And in this case it does. I can see it does. There isn't really too much to turn on and off, or you can't really do much other than that. I guess you can go in here and look at COGO points and that type of thing. Basically kind of shows me what the contractor would get. It's just a 2D line that has geometry associated with it. I don't know much more other than just open up these files, but if it is an alignment that has a profile, you should be able to click on this profile tab, and it should show you the profile, and you can basically, you know, zoom in here if you want to. I mean, you can't really validate much on it, I don't believe, other than just make sure it kind of looks like what you had planned to give the contractor, and it just gives you a non-proprietary viewer of an XML file. Let's say it's a terrain file, so I'm going to open up my existing surface. I can open that up. It'll take a little while to open up here. I want to be in a plan view, and here you see I've got all these basically these points showing here. I think it's probably some extra vectors in here or something. And this is showing me a spectrum. This is my existing surface, so I can see where that existing road is. And these are it looks like it's color coding based on elevation. You can do some things in this viewer to zoom into it like that. It will show you various things out here. You can do grayscale shading. Yeah, it's very limited, I mean, but it still gives you at least a visual that what you're giving the contractor is what you plan to give them. If nothing comes up at all, you know that there was a problem in your export, and so at least it gives you that kind of a check on it. Let me open up the proposed. So there was my proposed surface here. If I open this one up, it should look like my corridor, and I should have, if I zoom in here, and I'm going to go to the spectrum again. The zooming here, I haven't gotten myself trained on how this zoom works, but probably works more like another application. But I can at least start doing some validation on this. I do see where my break lines are, and it's shading it. If I didn't want it shaded, I think I can just go to a default or no shading, no fill triangles right here. And then I can see my triangles, how it would triangulate between those. Well, that's my proposed surface anyway. So any of the DGN files and DWG files, of course, you would just use a native application to view those, which is what we already did. So I just wanted to point that out. That is actually going to be delivered in the next release. It's this Land XML visualizer. And then there's a couple other Land XML things out here that I think Quentin's going to be addressing this one in the future. That covers most of what it covers everything that I planned to cover today. I wanted to at least go through, see if there was any questions, and see if there was any that were left over. That there wasn't too many questions here. It looks like they were answered. If you do have any questions on this, feel free to write them in. You can send them to our email address, ecso support@dot.state.fl.us, or you can just give us a call at one of our numbers. You guys know the deal. We take any and all calls. If there aren't any more questions, then we can go ahead and end this webinar. Thank you for attending.